Welcome to EDU World Space.
This question deals with the periodic table and some of the periodic properties. It especially talks about ionization energy. That's the energy required to strip away an electron. And we're asked to determine whether the given statements below that I've kind of summarized here are true or false statements. And what did I just say about ionization energy? The energy required to strip away a substance. It's an endothermic quantity. It requires energy to strip away electrons. So it will always be an endothermic process with a positive amount of energy going into the system to strip away an electron. So the first statement here saying that ionization energy is negative or an exothermic process is false. It's always an endothermic process, always requires energy to strip away electrons. Therefore, there'll always be a positive sign associated with the endothermic process of ionization energy. The second statement asks if the ionization energy of oxygen on the periodic table is greater than fluorine. Well, the general trend that we see for ionization energy on the periodic table is as we move left to right across any row, the ionization energy or energy required to strip away electrons increases. Well, check it out here. Fluorine and oxygen are in the same row of the periodic table, but fluorine is to the right of oxygen. That means fluorine should have a higher ionization energy than oxygen. This statement says just the opposite, so this too is a false statement. Question C says a second ionization energy is always greater than a first for a given species. Well, let's look at what that means. A first ionization energy strips away an electron from a neutral atom to create a cation and then releases an electron. A second ionization energy strips away an electron from that cation that was formed in the first step to form a +2 charged cation and again releases another electron. So if we just compare the two, this is going to be a true statement that a second ionization energy always requires stripping away an electron from a positively charged cation. That's more difficult to do, requires more energy because that positively charged cation is going to have a greater pull for its electrons and hold them more tightly than a neutrally charged atom, and therefore will require more energy to strip away any additional electrons. The final question here talks about a third ionization energy. So if we were to strip away a third electron, this is sort of what the reaction would look like. Take that +2 cation and strip away an additional electron to form a +3 cation. This is going to require even more energy than the previous ionization energy. And the way the question is worded is misleading. And reading it in the way that we do, it's a false statement. It says that you essentially are going to lose all three electrons from a neutrally charged atom all at once when you talk about a third ionization energy. And that's not what happens. This is a sequential process where you first lose the first electron from the neutral atom, the second from the positively charged cation, and a third electron from a +2 charged cation. And so it's not a neutral atom that's involved with the third ionization energy or even with the second. It's rather positively charged cations that are involved in the way the wording is directed for answer choice D is a false statement.